This is a COA question from cache memory. We have a set associative cache of size 2 KB. Let us note that down. The cache size C is 2 KB, which means 2 times of 2 to the power 10 bytes or 2 to the power 11 bytes. And in this cache, the block size is 64 bytes. So we can say the block size B is 64 bytes or 2 to the power 6 bytes. Now they're saying that the cache is byte addressable and it is taking a 32-bit address, which means this is the cache addressing format. First we have the tag bits, after that there is a set index, and finally we have the block offset. And in total these three fields are taking 32 bits, which we call as the physical address of the cache. And now they're saying the width of the tag field is 22 bits. So width of this tag field is already given as 22. And using this block size, we can calculate the block offset because the block size is 2 to the power 6 bytes. Hence, the offset will be 6 bits in length. So this offset is 6 bits. And now from 32, this is 22 and that is 6. So the set index will be taking 32 minus 22 minus 6, which is 4 bits. So we get the set index as 4 bits. And what does that imply? That the number of sets we will be having is 2 to the power 4 or 16. But what do we want to calculate? The associativity of the cache. And how will we get that? For that we need to calculate what's the number of cache blocks we are having. And how do we get the number of blocks? By cache size upon block size. And cache size is given as 2 to the power 11 bytes. And block size we know is 2 to the power 6 bytes. And hence that gives us 2 to the power 11 minus 6 equal to 5, that is 32. Which means in total we are having 32 cache blocks and 16 cache sets. And what does this imply? That every set will be having 2 blocks, 32 blocks and 16 sets, which means the associativity will be 32 by 16 equal to 2. And that implies that every set is having 2 cache blocks. So associativity for the given cache will be 2, and that is our answer.